These values are useful when we want to solve problems. Alright, let's now talk about latent heat and change of state. Now, this is an interesting and important phenomenon in thermodynamics. What does latent means? Latent means hidden. Now, when you supply heat to an object, normally you would expect that its temperature will increase. Now, sometimes when you heat an object, its temperature will not increase. Now, what happens to the amount of heat you supply at that time? That is the amount of heat you call latent or hidden. Now, you know, when I talked about potential energy, I told you the internal energy of a substance is made up of potential energy and kinetic energy of its atoms and molecules. Now, only a change in kinetic energy will give rise to a change in temperature. A change in potential energy will not result in a change in temperature. That means during the time the potential energy of the atoms and molecules either increase or decrease, there will be no change in temperature. Therefore, the heat used during that time will be hidden, will not be manifested by an increase in temperature. Therefore, latent heat is a measure of heat that is used in increasing the potential energy of the atoms and molecules of a substance. Now, you know that when you heat a solid, the translational kinetic energy of the molecules will increase up to a level when the solid reaches its melting point. At the melting point, what is going to happen? The molecules are going to break away from each other. And you know, when the molecules break away from each other, they gain potential energy. That means when a solid reaches its melting point, you keep on supplying heat to it, the temperature of the object will not rise. What is then happening to that heat? That heat is now used to separate the molecules from one another, to overcome the intermolecular forces, to increase the potential energy. Now, this is what happens during a change of state. So, during a change of state, there will be no temperature change. The heat energy during that time is used in supplying potential energy to atoms and molecules, in overcoming the intermolecular forces of attraction. When heat is supplied to a solid, the vibrational kinetic energy of its molecule increases, hence the temperature of the solid will increase. Now, this will continue until the solid reaches the melting point. Now, at the melting point, the energy is no longer used to increase the kinetic energy, but instead it is used to overcome the intermolecular forces to free the molecules from one another so that they are free to move about. Now, this time the potential energy of the molecules increase. Now, this time, this is the time when a solid changes into a liquid, a change of state. Now, during a change of state, the amount of heat absorbed or liberated, when a solid changes to a liquid, heat is absorbed for that change. When a liquid freezes to become a solid, that amount of heat is liberated. So, the amount of heat absorbed or liberated during a change of state is what we call the latent heat, hidden heat. During this change of state, the molecules do not speed up, but the extra energy is given in gaining the potential energy. And when heat is supplied to a liquid, when all the molecules have freed themselves, we can say the solid has now melted. All the solid has now melted. If you now supply heat to that liquid, the molecules will now start gaining vibrational or translational kinetic energy, moving faster and faster, and now the temperature begins to increase. And this continues until the liquid reaches its boiling point. So the translational kinetic energy of the molecules will increase until the liquid reaches its boiling point. What happens when you supply heat at the boiling point? The amount of heat now you supply is again used in freeing the molecules from one another so that they can escape the liquid body. The liquid changes into a vapor. This is the time when a liquid turns into a vapor. That means when a liquid changes into a vapor, heat is absorbed without changing temperature. When a vapor condenses to become a liquid, the same amount of heat is liberated, again without a change in temperature. And this heat is again latent heat, hidden heat. During this change of state, the molecules do not speed up, but the extra energy is again used to gain potential energy. And when a vapor condenses back to liquid, heat energy is given out, but it does not lower the temperature. It is simply the potential energy that is lost, not the kinetic energy. You see, temperature change is associated only with the translational kinetic energy. If the kinetic energy increases, the temperature will increase. If the kinetic energy decreases, the temperature will decrease. But an increase or decrease in the potential energy will not contribute to a change in temperature. Since the amount of heat absorbed or liberated during a change of state does not manifest in a change of temperature, this heat is called the latent or hidden heat. Now we use uppercase L to represent latent heat, and we will measure it in joules per kilogram. So latent heat is a measure of the amount of heat needed to change 1 kilogram of a substance either from solid to liquid, liquid to vapor, or liquid to vapor, or backward. We will define each one of them specifically. Let's look at the microscopic view of a solid. Now in a solid, the molecules can simply vibrate, and as you supply heat to this, the energy of vibration will increase. You can see they are more agitated, and as you keep on increasing or giving more heat, a time will come when they will break away from each other. So in a solid, the molecules vibrate about their fixed positions, and as more and more heat is supplied, their amplitude of vibration will increase. Their translational energy, kinetic energy will increase, thereby increasing the temperature. And the increase in temperature will continue until it reaches the melting point. You see? And at the melting point, what is happening? The intermolecular forces got to be overcome. So the amount of heat now given during that time is going to break the intermolecular forces so that molecules can now move about freely like this. So this is the microscopic view of molecules in a liquid. Molecules are free to move within the body of the liquid. Now what happened from solid to liquid? The potential energy of the molecules have increased now, and the amount of heat absorbed to achieve that is the latent heat. How about when more and more energy is supplied to the liquid, as the liquid is supplied with more and more heat energy, the translational energy of the molecules will increase. They will move faster and faster until a time will come they have sufficient energy to break away from each other. They are free from each other. They have more potential energy in the vapor. There you are. A molecule in a gas are not bound to each other at all. You see, there are no intermolecular forces. They have a great potential energy in the gas. In a gas, there are no forces holding the molecules together. And you can see here, when a liquid becomes a vapor, the vapor molecules are free to roam the space. All right? So, as we change a substance from solid to liquid to a vapor, the potential energy increases at each state. Let's now define specific latent heat of fusion. We are going to discuss two types of latent heat. One type of latent heat is the latent heat of fusion. The other type of latent heat is the latent heat of vaporization. Now, what does the latent heat of fusion involve? It is the amount of heat needed to convert solid to a liquid, the amount of heat absorbed during the time when a solid becomes a liquid, or the amount of heat liberated when a liquid freezes to become a solid. That is latent heat of fusion. And latent heat of vaporization occurs when a liquid changes to a vapor, that is latent heat is absorbed, or when a vapor condenses to a liquid, latent heat is liberated. So depending on the change of state, latent heat could be absorbed or liberated. Alright, what is the definition of specific? Specific is a certain amount. That means the amount of heat absorbed or liberated by 1 kilogram of a substance at its melting point to convert either from solid to liquid, that is heat absorbed, or from liquid to solid, heat is liberated. So specific latent heat of fusion is the specific amount of heat that is required at the melting point to convert 1 kilogram of the substance either from solid to liquid or back from liquid to solid. So what is the unit for measuring? We will represent latent heat of fusion by L sub F, and it is measured in joules per kilogram. How many joules of energy is required to convert 1 kilogram from solid to liquid? Now, during this time, there is no change in temperature. Remember, when you use latent heat, there is no change in temperature. For water, look at this amount of heat needed to change 1 kilogram of ice to water without a change in temperature. It is 333.5 kilojoules per kilogram. 3.34 times 10 to the 5 joules of energy are required to change 1 kilogram of ice to water at the same temperature. Ice at 0 degrees to change to water at 0 degrees, you need this much of energy per kilogram. That's a tremendous amount of energy.